Hello friends, welcome back to my channel. I'm Mr. Soen Chutke, helping you today with Daniel cell. Now, Daniel cell is a type of galvanic cells. So friends, we have earlier seen in the earlier parts of electrochemistry, we have seen that there are two kinds of cells. One are those cells which produce electricity, and the other kind of cells are those which consume electricity. So, आपका जो remote का cell है, that remote का cell is producing electricity. What does it do? It produces electricity. But how is this? That's called as a dry cell. How has this dry cell originated? It does not come directly, right? So before the dry cell, we had the galvanic cell, which was probably the first cell which produces electricity. And like your electrolytic cell is not to consume electricity, उसमें electricity consume होता है, इसमें electricity produce होता है. So let's see how this Daniel cell exactly works. So we're going to have a zinc electrode. Let me draw the diagram for you so that you understand it properly. So we're going to have a zinc electrode, okay, placed in a solution of zinc ions. That means we're going to have a zinc electrode placed in a solution of zinc ions and copper electrode placed in a solution of copper ions, cupric ions. Okay, so here we're going to connect the Daniel cell. I mean the two electrodes of the Daniel cell. You can see that how it works. Have a look at this. So this is the construction. What are we doing? We are doing the construction and working of the Daniel cell. So first we are constructing it, and then we will see the working of the Daniel cell. So we have two separate cylinders, as you can see. Okay, and in these two separate cylinders we are placing what? Zinc rod dipped in a solution of zinc ions, copper rod dipped in a solution of copper ions. Then I am placing a bulb over here, okay, between the two electrodes. This is our salt bridge. This salt bridge is having something called as KCl electrolyte. KCl, it's having KCl. तो आप सोच रहे होंगे कि ये उल्टा YouTube है, इसमें से KCl गिरेगा कैसे? नहीं, वो नहीं गिरेगा क्योंकि it is in a gel. Which gel? Agarose gel. Agarose gel में KCl को dissolve करके रखा है, तो it can ions can diffuse, but KCl is not going to fall. Okay, so very simple. Zinc rod dipped in a solution of zinc ions, to be specific, it is zinc sulfate over here, and copper rod dipped in a solution of copper sulfate with cupric ions in over here. So what is going to happen in this Daniel cell? Let's see. This is at anode. Who's at the anode? Zinc is at the anode. आप तो जानते हो कि anode पे हमेशा क्या होता है? Oxidation होता है. And oxidation is loss of electrons. That's how we remember. That's our mnemonic. Oil rig. Oxidation is loss of electrons. Reduction is gain of electrons. So at anode, zinc is going to jump into the solution, forming zinc ions. ध्यान देना यहाँ पर क्या हो रहा है. Now we have constructed the Daniel cell. Now we are seeing the working. Zinc is jumping into the solution to give in more zinc ions. Already zinc ions are there. It is giving you more zinc ions by losing two electrons. You can see loss of electron is happening because at anode हमेशा क्या होता है? Oxidation is loss of electrons. आपको एक बात समझनी है कि electricity current तब flow होगा जब one of the electrodes is at a higher potential and the other electrode is at a lower potential. So zinc is at a higher potential. You can see the standard reducing potentials, एक series electrochemical series. उसमें आप देखोगे कि zinc is at a higher potential in terms of giving electrons as compared to copper. Okay, so now what is going to happen is, as I told you, zinc is jumping into the solution to give away zinc ions and two electrons. These two electrons will be left at the anode. Where are they left at? They are left at the anode. So they are accumulating at the anode. Okay, and when they accumulate at the anode, obviously this comes at a higher potential, and then electrons start flowing, okay, from anode to the cathode. They start flowing from the anode to the cathode. Here the anode is having a negative sign. Yeah, in electrolytic cells the anode is having a positive sign, but in electrochemical cells or galvanic cells, you can say the anode is having a negative sign because it is having electrons being accumulated on the anode, so therefore it is having a negative sign, and cathode is having a positive sign. In electrolytic cells again it's vice versa. Cathode is having a negative sign in electrolytic cells, but here in galvanic cells it is having a positive sign and anode is negative. So these two electrons now, because they are at a higher potential, they start migrating to the cathode, and let's see what happens at the cathode. So at the cathode we will have reduction. Reduction is gain of electrons. So these Cu2 plus ions which are present in the solution, they will accept these two electrons, forming copper solid. So what you can say that these cupric ions will accept the two electrons coming in from the anode, and after accepting they will form copper solid and they will get deposited on this cathode. So at the end of the reaction you can see that the cathode is growing thicker and thicker, and the anode is diminishing in size or depleting in size because zinc ions are jumping out. Now when electrons are flowing over here, we know that when electrons flow in this direction, the current will flow in the opposite direction, and this bulb will glow. Now there is one more thing for the bulb to glow, that is the circuit should be complete. Okay. Now say for example, we are having this yeah, in this extension you can see that this is a wire. This is, say for example, the live wire, and this is the neutral wire. So you have to insert your device into both the live as well as neutral wire, and this is the earthing socket. Okay, so the live wire socket, neutral wire socket, and the earthing socket. So your you just insert your pin into the live wire and make the device work? No, that is not possible. You require the neutral wire to in order to complete the circuit. So only when you complete the circuit, then only the thing or that device can work. The electrical circuit can complete and the device can work. Okay, similarly, for this bulb to glow, the circuit has to be completed. This is one part of the circuit. You can say this is the live wire part of the circuit, but what about we need to complete the circuit? So for completing the circuit, we are having the salt bridge. The salt bridge not only just completes the circuit, it's like this now. Okay, it not only just completes the circuit, but at the same time it also functions as maintaining the it's functioning for maintaining the electrical neutrality. Okay, it functions to maintain the electrical neutrality. Now what is maintaining electrical neutrality? Like when zinc ions, more number of zinc ions are here. Earlier, you know, how the situation in this solution is that the zinc ions and the sulfate ions are equal, but now the number of zinc ions are increasing and the sulfate ions are not enough. Okay, the sulfate ions are not enough to combat or to maintain the electrical neutrality. Zinc ions are increasing. So when zinc ions increase, the moment one zinc ion increases over here, 2Cl minus ions diffuse from the salt bridge, and 2Cl minus ions will maintain the electrical neutrality by cancelling the positive and negative charges. The number of positive charges here are equal to the number of negative charges. How does that happen? The moment one zinc ions enters into the solution, 2Cl minus ions come out of the salt bridge. Okay, similarly here where you are having the cathode, what is happening is earlier the Cu2 plus ions were equal to the SO4 2 minus ions. The positive and negative charges were equal, but now Cu2 plus ions are depleting because they are converting into copper solid, and there is a decrease in the copper cupric ions, due to which the sulfate ions or the negative charge increases. So what happens? The K plus ions, 2 K plus ions come in place of one Cu2 plus ion. So therefore, this maintains the electrical neutrality. This is how the salt bridge is maintaining the electrical neutrality. So there are three functions of the salt bridge. One is it is maintaining the electrical neutrality. Second is it's completing the circuit. And third thing is allowing us to keep the two solutions separately. Otherwise, we would have to mix the solutions and it would be chaotic. So therefore, salt bridge is very important if you want this Daniel cell to work. Okay, and it is generating a potential of 1.23 volt. This entire cell is generating a potential of 1.23 volt. This is the construction and working of Daniel